Okay, let's talk whiteboard. So, there's a reason this is called a she task. Science is a human endeavour. It's because it's all about science, which has been done by humans endeavouring to do research. So, unsurprisingly, the majority of the assignment itself is focused on science as a human endeavour, with the impact of whatever has been researched being the most important aspect. And the secondary aspect is demonstrating how smart you are in chemistry or physics. So that comes next. But the majority of it is on she. And of that, we focus on allotting your evidence of she for whatever it is you're researching to CC dial. These are approximations. I should say the majority should be on she, and the minority needs to be on technical content. You must make sure that you demonstrate enough evidence of both to get some reasonable results in your rubric. However, you need to make sure that it's not a big assignment on technical chem and bugger all on science as a human endeavour, or tons and tons and tons on science as a human endeavour, but very light on the technical stuff. I have had assignments before which have had amazing technical chemistry and then just really generic she content, and they've ended up getting average marks. The same can be said for the she content has been just amazing, like A-level stuff, but then the technical chemistry might be down in somewhere the C or the D level. So it becomes very difficult to mark when you've got all this stuff at the top and all this stuff at the bottom, and you have to decide, well, is it going to be a B or is it going to be a C? That makes it quite difficult. After 9 years, I've learned to trust my gut feeling, to be honest. I can get a fairly good understanding of where it sits just by simply getting a feel for it. But in the first couple of years, it took a while to decide where things sat. This is not a history essay. There are a number of examples, especially if you're getting inspiration, shall we call it, or from ThinkSwap, that goes on and on about the amazing things that have been developed and researched and whatnot through the century. But we're not interested in the development of the lithium-ion battery from the first instance of whenever it was created. We want the latest stuff. SACE prefers within the last 5 years. If it's a sufficiently complex or interesting thing, you could push out as far as 10. People have presented me before, thankfully normally as a draft, a big history essay, big chemistry history or physics history essay, and I bounce it straight back to them. Yeah, it's not history. This is a she task. Be very careful about that. When I say approximately 40%, 60% there, if you're stage 2, we're looking at about 1,500, well, that's the limit, so 600 words for your technical chem physics and 900 for your she. For your stage 1s, 400 words and 600 for the she. Sometimes the most difficult challenge you'll find is determining what content to cut out. And I'm not the biggest fan of students coming to me saying, look, what can I delete so that I don't impact my grade? It can be very difficult sometimes, because unless you're going to formally assess the assignment, then doing it quickly on the fly, such as like one of those after school help sessions, without the ability to sit down and really concentrate, it makes it difficult not to, like, I can't guarantee that I might take something away that, you know, to be honest, when you read the assignment as a whole in a very detailed and much more thorough fashion, like when I mark it, it's just simply better if you learn to keep it to size. Don't write a bunch of stuff and then plan to cut it back. Build up to the limit. Don't build over and then cut down. Try to do that anyway. Now, when we're looking at the theory, so we're talking a combination of KA1 and KA4 from the rubric here, and to some extent KA2, especially if you're introducing concepts that go beyond the textbook, which is new technical content. If you regurgitate the textbook in an average way, you'll get a C. If you do a really great job of talking about the level of physics or chemistry that's in the textbook, you'll get, a B. If you're really good, maybe an A minus. But if you really want to get to those upper echelon A areas, you at least got to have one sort of area where you're demonstrating a little bit of research and analysis beyond what's in the textbook itself. So it doesn't necessarily have to be something that's harder. It doesn't necessarily have to be something that, you can't grasp without significant amount of work. It can just be something different. It needs to be new. And remembering that the target audience is a stage 2 student. So if a stage 2 student's not going to get it, then, you shouldn't be putting it in there. If you're stage 1, then your target audience is a stage 1 student. If you can't hand your assignment to a fellow classmate and they can understand and learn from it, then you haven't written it properly. And I'm going to make the assumption that you don't know what you're on about. It's not so much an issue for stage 1. I can do whatever I want there effectively because it's not moderated. But stage 2 stuff goes to Adelaide to get checked. And if they see a university standard paper, they're going to make the assumption that you've copied it or you've had someone else like your tutor write it for you. This is why it's important for those A+ level assignments that we make sure it's an A+ for a stage 2 student, not an A+ first year university or second year university level assignment. We don't want to attract undue attention. New and not familiar. So yeah, I've covered that. If you want a better mark, you need to get some content in the technical chemistry or physics. It's just that little bit beyond. For you stage 1s, that can actually be quite easy. You go and get the stage 2 physics textbook and you can use some of the content out of there. Considering though that I'm limiting you to nuclear, that can be an issue, but if you're thinking the synchrotron or the fusion reactor, the movement of charged particles in magnetic fields is something you can grab out of the stage 2 physics textbook. You can use that to get an A, and every moment of time you spend learning about the movement of charged particles in magnetic fields in stage 1 is not wasted because you're going to do it again in stage 2 anyway. So when I'm talking about these really high-level papers and assuming that you don't know what you're on about because you haven't written to your target audience, which is one of your fellow students, big words, high-level concepts, all that sort of stuff, especially when I've done an honours degree in chemistry and I read a paper and I'm like, I've no idea what's going on here. Well, it raises questions. And the concern with it is that it's not necessarily that you don't understand it, because we can bring you in and we can question you like police and record it, and we can send the recording down to SACE, and that demonstrates that you know what you're on about. But it's also part of the communication thing, because I've set the limitation on these assignments in that you have to be able to use this to educate one of your fellow classmates. That's a limitation I'm placing on you. So if you make it a paper that's totally inaccessible to the teacher, let alone the students in your class, then your KA4 grade should really be downgraded because you haven't written to your target audience. And remember, it goes to moderation. I can question you. I can bring you in and say, Barl, explain it all to me. And then you do a great job of that, and then here's your A+. Thing is, though, when it does go down to moderation, now it doesn't necessarily get accompanied by it's not supposed to be accompanied by a video of you explaining it. That's not part of the assignment. That can't be part of the assessment. I mean, it's a way we can confirm that you know what you're on about. But the thing is, if a moderator opens it up when you're a stage 2 student and they look at it, it's just full on and they don't understand it. And they don't have the ability to question you because you'll be off, enjoying the end of school. You're going to possibly get that A grade downgraded to a C. And it's happened multiple times. So just be wary of any of that big word, high level stuff. If you're concerned with something you're writing, show it to one of your classmates or show it to me and just check. And then, that'll help you to make sure you're not going off the rails with that. Non-word based communication. Right, so you have a word limit, but you can get over that word limit a little with some information by using graphs, technical diagrams, relevant pictures, data, whatever else you want to put in there. But also non-word based communication, which is part of KA4, is a great way to break an assignment up. I don't often allocate really high grades to assignments which are just black and white words only. The higher grades tend to go to the subjects, to the assignments which have pictures, which are relevant, which have formulas, whether it's a physics mathematics formula or a chemistry chemical formula, that have data and technical diagrams, and they're not just dumped there. They're not just sort of left in the middle with no reference. They're you know, as can be seen in figure 1.0, which has its own little, you know, it's got a reference and everything, and you tell me why it's there and what I'm supposed to be looking at. And if it's a picture with words in it and I need to be able to read them, it's not tiny. You drag it out till it's filling half a page. The length the document is irrelevant. It's a word count. You could put all the words in size 25 font. I still have to mark it. So make sure I can see the pictures. If you just dump a photo in there because it's a nice to have, like, you know, let's do the Chernobyl dome over the reactor, and you just dump a picture of the dome. I'm like, yep, pretty dome. Anyway, let's go on. I'm gonna pretty much like ignore it. It doesn't contribute to your grade. So it's like putting things in the appendix. I'm not going to look at it. We only look at from word 0 to word 1000 or 1500, and that's where the evidence lies. If it's not in there or it doesn't contribute to those words, then it's not part of what's considered. So if you are going to put diagrams, more often than not, it's better to make sure that you make it really obvious to me why the diagram's there and what it's helping to show. It's important that when not just a classmate or anyone that reads this, but when I read this, you don't make it difficult for me to have to pull this stuff apart. You need to demonstrate that you understand the theory and the technical chemistry, and you need to be able to do it in a logical manner which flows and which has relevance to the topic you've chosen. If you make it really, really difficult for me to see the evidence and to pick it apart, then it's going to be difficult to start bumping you up to the high level areas. When you read an A-level paper, it's a bit of a breeze, to be honest. You read it, it flows well, the language is really good, it's accessible to the target audience, and you get a real feel for the fact that the person that's written it understands their topic and they're interested in it, and they've gone out of their way to do a bit of extra research to find out, you know, the latest things and what's to come. Yeah, that's a big part of it. Make sure you reference. You especially need to reference anything which is a fact or a figure or an opinion or anything like that that a stage 1 or 2 chemistry or physics student couldn't be expected to know in general. And if it's a comment that a chemistry student or physics student would know in general, then I'm not really sure why you're referencing it. For example, when people do titration practical reports, they might go to Wikipedia and reference the definition of what titration is. That's just a waste of time. I only reference things which are not common knowledge. Go out and find really great quotes and opinions from scientists. Go out and find facts and figures which support the technical chemistry or physics, and reference that stuff. Don't reference generic rubbish. And the generic and general, you see these sort of words like general appear in the C band of the rubric. In general, in general. You want to avoid in general stuff. You want to be looking specific. Alright, that's enough on the technical chem. I wonder how long I've ranted for. Alright, 15 minutes again. Not bad. I seem to be getting on just the right time here. Stop.